what mass of carbon dioxide is needed to make a 300-pound oak tree?
We have an equation for the photosynthesis. We know we need these two things, and we know we're going to end up with what? Cellulose,
Right.
but that's just a polymer from
Glucose, there you go.
From glucose.
All that carbon there came from CO2.
Obviously comes from here. It's the only
We
place we
have
can
to
get
assume
it.
that.
We know we've got 12 hydrogens, so we know we have to have 6 of these at least just to get that. So we know we can have O2 over here. And since we've got 12 left over, we might as well just do that.
Right, so then there's 6 plus 12 is 18 oxygens, right? And then
Yeah.
6, then 12 is 18 oxygens. Okay.
And since we're finding mass, we can
We have 300 pounds of tree, but only 60% of that is
60%.
glucose.
60% of it is glucose.
And
we
the
know
tree
that
is 300
The tree is 300 pounds. We've got this math stuff here, but it's all going to be in metric, so we know we're going to have to do some converting.
The periodic table tells us grams per mole.
Grams per mole, so we know we're going to have to convert pounds to grams, and we have a conversion there.
Right.
1 pound is 454 grams.
Right. We probably want to know how much these weigh. And the goal is we want to know how much of that
How much
made,
made this.
how much of this do we have if we have a 300-pound tree?
And I'm going to shrink this down because it's a little bit in the way now. How do we want to approach it? Since we know we have 300 pounds, we can figure out what 60% of that is. But we can work backwards this way. Since
But we need to know how, because this gives us basically a ratio of this much of this came from that much of that. So if we know how much of that we have of the glucose, then we can figure out how much.
how much CO2 we needed.
We have a 300-pound tree, but only some amount of it is glucose.
So 60% is, so 0.6 times
We have 300 pounds.
300 pounds.
So 6/10 of 300 pounds.
And we know we're going to need that, and we can convert back later. Do you want to go ahead and convert?
I think
to-
we need to do convert now.
So we know that we have for 1 pound, 454. This is just a ratio. This is unitless, so we don't have to worry about that. And since the unit we're looking for at the end is in grams, we know that we have to convert pounds to grams, and we get
Grams.
that.
So 0.6 times 300 times 454 and divided by 1, it's still the same.
81,781.
81,
720.
720
81720?
grams.
The equation doesn't work with grams. You don't know that 6 grams of CO2 make 1 gram of C6H12O6. So there's something we're missing.
So
So
we've
we need to
gotta-
change those grams to moles somehow.
Which is what we're gonna, yes.
We use a periodic table to add, right?
Yeah.
1 mole of carbon
1 mole of
weighs
carbon
12
grams.
6 times 12
And then plus,
grams plus 12 hydrogens, and hydrogen is 1 gram, so we say 12 times
One.
1 gram plus 6 oxygen, that's what, 16?
Yes.
So 6 times 16.
okay, so now we
This
need
is
to add all those
confusing
up.
now. Wait, yeah, this is information we have. I'm gonna put it over here in our stuff we have category. 81,720.
720
20
grams of glucose.
grams.
You can make it.
So now we need to add that up.
96, 12, and
And plus the
We
minus.
got 180, but let's check that.
180 grams. This is all in grams.
For
So
1
that's our-
mole of C6H12O6, there's
Yeah.
72 grams of carbon,
Yeah.
12 grams of H, and then 96 grams of oxygen, and you stick them all together, and that means 1 mole
1 mole of
of
that
that.
is 180 grams.
Yes, 180,
80
Grams per
grams per mole.
yeah, okay.
Sweet. So 81,720
Grams.
grams.
But we know we need to make that not grams.
We need to change it to moles. So we know we have 81,720 grams. And we know what our conversion is. It's 180 grams per mole. 180 grams per mole.
We want to get from moles of this to moles of that. So we would say grams glucose. And this is actually, we're talking about moles of glucose here.
Okay.
So right now I have grams of glucose gone, right? But I have moles of glucose, so I need moles of glucose on the bottom, right?
Dioxide.
One here and
Okay.
6 here. So 6 moles of CO2.
We gotta go towards
Moles of glucose goes away.
Grams, we want to go back to grams.
So we need grams of CO2 as well.
yeah. Well, we'll eventually need pounds. So yeah, we'll have to go to grams and then we'll have to convert.
Oh, and then we have to go back to
Yeah, we have to
pounds.
go to pounds. from
Okay.
there.
We don't have a conversion yet for CO2, do we?
Oh, let's do
I
that.
got
then.
it.
It's 44 grams
So we can
for
put that away.
1 mole.
Yeah.
Of
Okay.
CO2.
44 grams per mole.
Yeah, so that's 16 plus 16 is 32
Yeah.
plus 12.
And you just did that the same way we did the glucose one, right? You took
Exactly.
carbon times 1 and oxygen times 2 and then added them
Right, so
together.
32 plus 12 is 44.
44.
So we need moles of CO2 to grams of CO2, right?
Yeah.
We want moles of CO2 on the bottom. 1 mole of CO2 weighs
Weighs
44.
44 grams. So now we can cancel mole CO2.
So now we have grams of CO2.
Should we go back to pounds since our answer
We should
pounds?
convert back to pounds from grams.
Grams of CO2 on the bottom.
Grams CO2.
So I guess you don't need the CO2 part. You just need to know that grams are equal to
Grams
some
to
number of
pounds.
pounds for
this,
everything.
For this conversion, though.
This conversion
not-
is for
it's not
everything. So
necessary.
what was 1 pound is 454 grams.
454 and 1 pound.
Cross your grams out, and my grams go away.
That's why I wrote CO2. See, that was confusing me. Just so I know what
That's
I'm.
true. So now we have pounds of CO2. So you just have 1 times 81,720. So clear 81720 times 1 times 6. I don't know about you guys, but I do all the times and then I do divides.
I was doing the
afterwards.
same thing.
Divide by 454.
We've decided what? That it's
264 pounds of what? My teacher gets mad if I don't say of what.
CO2.
Okay, so
Yeah.
you can also work it forwards again to check.
Go back the other way with that number.
Maybe we can do the next problem, make sure we get that done before we have to share our answers, and then we can come back and check it.
Oh, we didn't even look at the thing here because 26.4 isn't one of our options.
That's a
That
lot
would
of
save us a
time.
lot of trouble there.
I'll read the next problem.
Okay.
Okay.
When you hear of people speaking of their carbon footprint, they are talking about how much carbon they put in the environment, not how much carbon dioxide they put in the environment. Is it possible to carry this problem one step further and report how many pounds of carbon are taken from the air to form the 300-pound tree?
Okay, so it's asking about pounds of carbon versus pounds of CO2.
I mean, all
I
we have
think
to do
that's-
is change what our conversion is, right? I
Right,
mean,
the
it's
same
all
thing we
the rest
did.
is the same because you have the same stoichiometry with carbon.
Or from the answer you already had. So we have 264 pounds of CO2, right? So we'd have to convert that back to grams and moles, right?
Yeah, that's-
Can we just do the
that's gonna be-
proportion of like the ratio of weight that's due
CO2
to carbon to
carbon?
oxygen?
Oh,
so
I see what you're
Yeah,
saying,
so
yeah.
just-
So what fraction of this amount of pounds is
Is
carbon?
carbon.
Yeah.
I could definitely see that.
So that-
12 of 44.
12 parts carbon to 44 parts CO2.
Yes. So this fraction
That fraction
of
is
264.
264 gives us so 72 pounds carbon. Our reasonings were still good, right? Because we know that that's just the amount of CO2, and we just want to know carbon. 72 is a choice. 20, what are the other choices?
27 and 180 pounds.
Let's see. If it was 180, that's like half this.
I mean, it kind of makes
Not
sense.
Well, I mean, this works with our little ladder thing. If you do 12, in this case pounds, because it doesn't matter if you're talking about pounds or grams, it's the same stuff. 12 pounds of CO2 or carbon per 44 pounds of CO2.
Yeah, those,
Right,
those
but-
units
and
just
then-
cancel each other. See,
And then
that's
we
the-
have 264 pounds of CO2, right? 264 pounds, and I'm
Yeah.
putting pounds CO2 on the top
Yeah.
so that it goes away.
But just to be clear, this makes it look like we're canceling these pounds with these. But
Yeah.
this fraction here to me would generally, when we use it here was different. We just said it was unitless because these pounds canceled these pounds. So Just wanted to make sure that we were clear about how we were doing that. This will work in just about any case that you have to make that you need to scale something by some factor like that.
I think there's two different ways of thinking about it. I think you can do it that way and you have your units, but then you can also look at that fraction as just like the percent.
So if you're just dealing with the percent like that, then it's,
Yeah, then you don't need against units, but I think both
Yeah.
methods are valid. Well, I think we got
did we have?
72.
was that
Are there
all?
any more?
That's it for now.